pleasure to introduce my colleagues Markus Schüttler and Stefan Hohenadel for their talk, Automotive Visualization at Scale. Before joining TNG, Markus was already interested in complex software problems in the field of OH planning and the simulation of X-ray experiments. And at TNG, he's currently working as a full-stack developer. And in addition to that, he also enjoys software architecture and requirements engineering in a modern cloud environment. Stefan is a PO at the business unit Automotive Visualization Platform at Audi Business Innovation, where he's working on the content on demand solutions. There we started in 2019 with one team and a few touch cases and a few hundred assets. Now he's leading 3 highly specialized teams working on their multi-brand, highly scalable 3D content on demand solutions with an ever-growing number of customers and hundreds and thousands of assets produced. So I'll hand over to you and enjoy.
Thank you, Matthias, for that very warm welcome. Markus and me, we are really happy to be here and to give you some insights in our story about automotive visualization at scale. But before that, you all know probably, does it work? No, it does not work. Okay. You know, probably everybody knows TNG and who that is, but maybe not everybody knows who the Audi Business Innovation is. So just some words about that. The Audi Business Innovation GmbH is a subsidiary, 100% subsidiary of the Audi AG. We are located in Munich here. We have 3 offices, a bit more than 200 employees, 18 nationalities. We have strongly enforced a modern working culture at our place. So we have flat hierarchies, strong feedback culture, and all that things, self-organized teams. And we are focused on business and IT. So we do not build cars, but we are focusing on the IT and the business around that. And the Automotive Visualization Platform, or in short, AVP, is basically one department of the ABI. And we are basically having 2 focus fields. The one is the digital retail focus field, so everything in visualization that takes place at the dealerships. We are there involved since around 2015, stronger 2016. And then the second big major focus field is CGI, so content production, so generating images, generating videos, and a lot more. And we have started already before 2019, but the strong basically impact and the strong engagement in that topic is since 2019, basically. We have 21 teams, just some small teams, but also larger teams. So big diversity in the team setup. And we do not only provide our solutions for the Audi AG brand, but also for other brands in the Volkswagen group like Lamborghini. And at the moment, we are basically strongly involved in adapting Volkswagen and SEAT, and probably more to come. So let's step back one step. Why does visualization matter? I think it's quite simple, because scientists say that around 60% of all the environmental perception we have as a human being is visual, and the rest of the 40% is audio, haptical, and so on. So if you apply that knowledge onto, for example, a website, we see here the Audi AG website, the configurator. If you imagine you do not have any images of the product, it's really hard to understand what the product is about. And you cannot really say like, okay, I will choose that product and I will maybe even buy that product. And even if you go further, if it's about configuring the product and you have interior options, like I can take that leather seat with beige color or with black color or with gray color, and you just read the text, you don't have any chance to understand what is the product all about. So what you really every time need is visualization of the product scope, of the product details. And this is why visualization for the automotive industry especially is very important. And in general, I think it's very important in any kind of product you want to sell in the internet. You always need an image, you always need a video, and so on. So when you look at the websites, that this does not only apply for Audi, that applies basically for all the car manufacturers. You have a lot of types of images, like small images, detail images, videos, all that things. And you basically, within the website, for example, you have millions of different types of images that you need to take care of, and and you need to produce them. Basically, they are not there out of a sudden. You need to basically enable processes and technologies to produce those images. And you can imagine that this is a very expensive procedure, and it's very difficult to create synergies because a lot of teams are involved. Some are taking care of the videos, the others are taking care of the images, and so on. So that's basically a huge problem. And this is why the AVP started in mid-2019 to think about how we can basically make these processes better, to create synergies, and of course also to make them cheaper. This is basically always the thing you need to do, either cheaper, better, or faster. So we had big goals. We wanted to basically conquer that whole content field in terms of content production. But the thing is, we had very good experience in terms of retail visualization. So we knew we have created our solutions. They were rolled out at the dealerships. It was a real-time solution, basically, where you can, or it is still a real-time solution, where you can configure your car in real time at the dealerships. You can even visualize them in VR. We built up a solution based on the Unreal Engine. So it was a very modern approach, basically, and we had a very strong backbone to be able to transfer all that data, all the 3D data that is necessary to visualize a car in its whole complexity into that Unreal Engine, and to make sure that the performance is good enough for VR. This is basically where we have been, 2019. But the problem was we could not create an image. So we could not render a PNG or a JPEG out of that. And we could not even create a video like you see here, a product detail video of a specific configuration. And of course, we could not create configurative content like you already know it maybe from a configurator on the website. So basically we had nothing but the real-time engine that was used in retail. So now, in beginning of, I think it was the 1st of October, like where we started our work, we knew that we had to go up to that mountain, but we had no clue how to. And even we know that we had our goal, our far goal, our basically the queen of every visualization basically is the car configurator. This is the most complex product you can have in visualization, but we did not even see that peak. We did not know where it is. We had no clue how the route is going to be take us, and how to deal with such a situation where you basically do not know how to start. Well, in my experience, I have for myself developed some kind of very basic pattern to try to approach that kind of questions in the last 2 years. And basically I use that pattern still when, for example, a new customer comes to me and asks me, can I use your visualization? And I want to share this pattern with you. And to understand that pattern, you have to, or I want to show you the basic challenges of visualization that we usually face every day. The first aspect of that is product complexity. So a car is a very complex product, and if you imagine that a car can be configured with different exterior colors, interior colors, rims, options, packages, right-hand drive for the UK market, left-hand drive for all the rest of the world, and so on and so on, then you end up with a product complexity of easily millions of variants just for one car. And a visualization needs to ensure that all of these variants can be displayed and can be rendered, basically. And if you then think about a manufacturer usually has around 20 cars in its offer, so it multiplies by 20. And if you then imagine that every car is even updated at least twice a year with some life cycle or product increment stuff and facelifts and so on, it even gets more and more complex. So it's clear if you do not understand and manage this complexity, you cannot visualize for automotive for an automotive purpose. And in terms of when I want to understand what kind of visualization a customer needs or a use case needs, the first question I ask is, what is your product scope? So do you want to just visualize one car, or do you want to just visualize maybe a certain configuration of one car or 10 configurations, or do you want to visualize everything? This is the first important question. The second important aspect is that visualization is always a question of aesthetics, UX, visual quality. And I think this is one of the most difficult things to talk about, because visual quality is you cannot measure it, basically. If you ask 10 colleagues of mine, what makes best visual quality, you will probably at least get 5 different answers. So there is no common understanding about visual quality. But there is common understanding about, for example, UX. What does an image need to be in terms of good UX? Or let's say the other way around. You cannot ask for, it's difficult to ask for visual quality, but it's easy to ask for how fast you need that image, how much computing time I can spend, because the more computing time I spend into an image, the better it is. The best example is the resolution of an image, of a full HD image, for example, takes just a fourth of the computing time as a 4K image, just roughly. It's not exactly that, but just roughly. So the second question I ask is end-to-end delivery performance. How fast do you need that image? And the third thing I need to understand is touch points. So the third challenge is touch points, which is basically, so let's say 10 years ago, the number of touch points was quite small. You had a website, maybe some app, and that's it. Nowadays, you have a lot of different touch points, especially because of you have to play out your visualizations on Facebook, on a lot of apps, on any social media channel. So it's a lot more challenging for visualizations to serve all those touch points, and they are more demanding. They want to have more images. So the third question, therefore, is what is your throughput? So how many camera perspectives, for example, do you want to have? How many visitors does your touch point have? How many calls per minute, calls per day does your touch point have? And then with this numbers, we can basically say, okay, you have a certain number of throughput in terms of number per images per hour, for example. And with all of that, basically you can describe basically every use case for in terms of visualization. And with that 3 questions, it comes to the basically 4th KPI, which is the most important actually in terms of business, price per asset. So if an asset costs me, let's say 1 cent for a production, one image costs 1 cent, rendering in the cloud is still expensive in terms of 3D visualization because you need strong hardware. 1 cent doesn't sound too much, but if you have 1 million images per day, you easily pay 10,000 euros per day just for rendering, which is probably too expensive. So when we go back to our journey, that use case pattern should help us to understand where we could start. So we have to find use cases that are easy to handle at the beginning in terms of those triangles. So we started basically not with a very complex cloud setup or whatever. We started with a local asset production, meaning the first tool we developed was a basic desktop application that connected to a 3D rendering instance, which was also running locally. And we, with that tool, could produce the first images. Therefore, we could basically gain experience in terms of, does it work? Does it look good? Can we describe in our render jobs what we need? Do we receive the correct results, etc.? And at the same time, we could already create value, because with that solution, our teams in the AVP were able to produce the first images, which could be immediately deployed on our touch points on the website or whatever. So we immediately created value, because those images have been a lot less expensive than the images of the previous productions that we basically wanted to improve. So if you look at the triangle, this was a very simple use case, because we had a fixed scope in terms of we just defined which kind of car we want to render, which kind of camera perspectives. And it was basically a pre-produced scope in terms of production time did not matter, because we produced it and then we uploaded into any CMS, and then that's it. And the number of assets were very low, because one production actually had maybe less than 100 assets usually per production. Then the next step was the so-called digital giveaway. The digital giveaway was the first cloud application we developed. It's some kind of microsite that the dealer can create and then can send out to a customer if he is interested in a certain configuration in a certain product. In that case, it's the Q5. And it's a microsite that he can basically check at home or send to his friends. And in that case, when you look at the triangle, it was the first time that we were able to produce a full scope. So every car could be visualized in that setup. But still, in terms of rendering time, it was okay if it takes several minutes to produce that assets. And in terms of throughput, we already had the case that we produced around 80,000 assets per week. Not so much, but a lot more than before. Then, some months later, we launched the first application basically on the Audi website that we played with our content, which was the e-tron GT Customizer. It's some kind of simple configurator where you can choose your lacquer color, you can choose your rims, and you have a 72 images turntable that you can use to experience your car. And in that case, it was the first time that we basically produced on-demand content. So that content needs to be available on demand on the website. It needs to be real-time, basically. And last but not least, the last step was not an Audi case. Basically, in April of this year, we have launched the Lamborghini Web Configurator. Basically, we haven't launched it. There was one before, but we basically reworked it with our solution. And this was the first time that we basically built a full scope configurator in terms of when you, again, check the triangle, check the use case triangle. We had the full scope, so every Lamborghini could be configured. It was an on-demand solution, so every image that is produced in real time on demand with our cloud infrastructure. And we had a throughput, or we still have a throughput of around 1.5 million assets per week. Yeah, so basically, that's the product perspective of how we basically approached our road to the peak of the mountain. Sorry, I thought there was one more slide, but anyhow, I'll hand over to you, Markus, and now you will get a bit more insight about the technical approach.
Yes, thank you, Stefan. Exactly, now that you all know why we're doing realization at scale, I'll give you a quick overview of how we got where we are now, and small technical insights as well. So I've here the timeline that Stefan has just described again, just as a reminder. And at the very beginning, we have the local asset production that Stefan has mentioned. So for us, from a development perspective, it was very nice that this was local, because local is just so much easier than cloud. You don't have to deal with, communication. Everything is on one PC. You don't need to figure out where to store your images, because you can just drop them on your local file system. And overall, this meant for us, we could focus on the image production itself and didn't have to deal with all the complexities of a cloud setup. in the very beginning. And another thing that was actually very local was our user base. As it turns out, we started with one user, and that user was sitting in the same office as Stefan, which for us was a very big benefit, because that meant basically from our first sprint onward, we could just grab the first build that dropped out of our pipeline, take it, run over to the desk of Giovanni and show it to him and get feedback on what worked and what wouldn't work. So that allowed us to very efficiently iterate over our product back then. Now, if the live demo gods are with us, I would like to show you roughly how that looked back then, or how it looks if you do local asset production. So here we have our local production tool, the automotive render tool. And well, this is the rather recent version. Basically, the skeleton is still the same. And the principle of this tool is, yeah, a little bit different than how you would create images if you only had the render engine itself. Because if you just have the render engine, you basically go to your graphics workstation, you start your render engine, and then you need to load the environment or level, I guess, in a game engine sense. And afterwards, you need to load a car, and then you rotate your camera, or maybe you even have a preset camera. And then finally, you can make your screenshot and you have your produced asset. And I mean, that works very nicely if you just need one picture every once in a while. However, if you want to regularly produce bigger series of images and preferably reproducible, and maybe, as Stefan has mentioned, there's a model change, you have the same car model and you want to reproduce all the images from, I don't know, 2 months ago, just with the updated model, you really don't want to do that manually in a render engine. So what our tool allowed the user instead was to specify how an image should look like, or what should be in the image. And this starts, of course, with the most important part, the product, or in that case, the car. For example, here I've configured an e-tron. And well, this is basically the whole configuration of how this car looks like. I mean, as Stefan has mentioned, there is a lot of complexity, and every one of these character combinations represents one of these configuration options. So whether it has the sports package or not, or whether the steering wheel is on the right or the left side. And all of these combined represent the car configuration. And by the way, this so-called PR string is actually a company-wide standard. So this is understood from our visualization to the configurator all the way to the factory, I think. Which was actually, for us from an IT point, pretty surprising that such a standard exists, and actually very handy. So the next thing you want to configure is the environment where you want your car to be placed. So in that case, the level to load. For today, maybe we pick the Allianz Arena. I mean, we could also pick the moon, but maybe we stay a bit grounded. And over the years, we got a lot of different options here, but for today, I will stick to the ones that we basically had from the first 1 or 2 versions of this tool back 2 years ago. And then, of course, you need to specify the resolution you want to render in. Maybe you want some oversampling to reduce aliasing artifacts. And then you select the cameras you want to have. So basically the angles from which you want to make pictures of the car. And that's pretty much it. The only thing left to do is tell the tool where to place your images. And I'll now select another folder and hope that we get some images there. And all left to do is press the render button. And now we hope that, not in this folder, because this was a probe folder, but in the live folder, we get some images of an e-tron in front of the Allianz Arena. So let's check. Okay, it opened on the other screen. 1 second. All right, yeah. Where's the Allianz Arena? There. Okay, good. So that works very nicely. And was very, very quickly in production, and actually helped, well, the small but very dedicated user base to better produce images. Now, the other thing you might have spotted here is that there are There's my mouse cursor. That there are more buttons than just the render buttons. That is because, well, now that we've created this declarative specification of what should be rendered, of course, it makes sense to save that in case we want to use it again, maybe in 2 months when there's a new car version coming out. That's why we have the possibility to save these so-called render jobs. And these are basically JSON representations of what we just set up here in the UI. And that means you can load this whenever you want, or if you're crazy enough, you could even edit the JSON and don't even need to go through all the UI options if you get too bored of, clicky bunty UI. So let's find back to the presentation. Okay. Should have put that slide, I guess. So as you've seen, basically this tool is not super complex. So what we have is the UI that allows you to specify this render job specification, basically what image should be in the end. And then, somehow there is a render component that knows how to read this render specification, this render job, and how to control the render engine in the end. This one is called, so this is the render engine that was already there at Audi Business Innovation. Basically the one that has already been in use for years at the dealerships as a retail tool. And now basically we taught this render engine how to produce images on command. And this logic is contained in the render component. And I mean, the only thing left to do in the local use case is, figure out where the files are saved on the hard drive. That was the easy part. So the next part was the digital giveaway. So this was our first cloud or API use case. And things promise to get a bit more complex, but as compared to the big mountain peak in the far distance, the web configurator, where basically we had to replace a production system, the digital giveaway was a new product. So we didn't have to meet some, I don't know, KPIs or load numbers from day one because it wasn't in use yet, it wasn't in production. So we could gradually grow with the product. We could gradually ramp up the load on the system. So we had a bit leeway there. And another thing that actually helped us a lot was basically one of our first architecture decisions. So I think this was one of our first whiteboard pictures, even though it's now white on black, because we quickly realized it doesn't really matter whether you produce the images locally or whether you want to have an API that knows how to produce images. You can still use the same render job description to describe how an image should look like. And this in turn means that you can also reuse the same render logic to go from this description to the final image. So the only thing that you need to change is, you need to have your render engine not running anymore on your local PC, but you need to shift it somewhere in the cloud. Luckily for us, there was already a team at Abi putting the AVE in the cloud for a different use case. So even there we could profit from the work done before us. But basically for us, this meant that even though the digital giveaway was new and no one was using it yet, so we didn't get any user feedback for it, we could still iterate over the UI production where we had that super efficient feedback cycle with the on-site user. We would get every week feedback what we could improve, and we could thereby improve the render component, improve the image quality, improve or remove bugs if there were any, I don't remember, and get to a state where the capabilities of the API were always on par with the local production, so that even though we didn't have any load on the system, any users, we were pretty confident that everything would work once we had users. But of course, as promised, there was a bit more complexity in the cloud, because now not everything is anymore running on the same machine. You don't have the single node process running that's doing all your work. And I mean, we already knew that at some point we had to scale things up, so we break our application apart. Now, basically, we had an API part that was hosted as Lambda functions on AWS. And we had our render component was a containerized task, also on AWS. And as I've already mentioned, luckily we already had these render engines in the cloud that we could simply access via HTTP. Now I skipped one ahead, but the problem is, of course, now that everything is in the cloud and asynchronous, you don't really want to directly put your render job into the render component once it arrives at the API, because you don't know. Maybe there's 100 customers coming at once requesting images. And when that happens, the render component wouldn't have the capacity to process all of it at the same time. So what we did instead is we added the queue to our system so that all the render jobs would first get put in the queue. And afterwards, the render component could pull the items out of the queue whenever it had capacity to render the next image. But that also meant, of course, the API had to know when something was actually done. So we had to add a database. Luckily, AWS has some services for that. In that case, we use DynamoDB. And maybe most importantly, of course, we also needed to store the image somewhere. So this was done in that case on AWS S3, so a simple storage solution. And that was basically our first cloud setup, which run actually pretty well and helped us to get the digital giveaway going pretty easily. But of course, there was the customizer on the horizon, and the customizer was a bit bigger. So the difference is for the customizer, basically, we would need to preload these customizer applications with all the images it required. And as Stefan has mentioned, there's a lot of combinatorics that end up with a lot of images. So some, I don't know, time in the week before a new car launch, someone would come and say, hey, we need a few 10,000 images for this new car. Which so far our API wasn't quite used to. So we had to work a bit on the scalability of our API. And another thing that we had to work on was the integration in the existing IT landscape of basically, the Audi digital web landscape. Because there are, as Stefan has mentioned, multiple touch points. I mean, the customizer was the first one for us, but it would be very difficult to sell if we had now to go to every single one of those touch points and tell them, hey, we have a new API. Why don't you get the images from our API instead of the one you're already using? Because then everyone would say like, no, I like the images I'm getting, just go away. But luckily, there was already luckily, there was already an interfacing layer in between, the so-called media service, that was actually providing the images for these touch points, or in that case, the customizer. So that meant we only had to talk to those guys, which, to be honest, was also easier for us only to talk to people who are already experts in interfacing. And well, on our side, we also had to ramp up our scalability a little bit, which for us meant that we split our render component a bit apart and removed the orchestration part. So basically all the logic where jobs get pulled from, how they get distributed was now in a separate part of the application. And that meant we had an easier time ramping up the render components to the required number of instances. The rest stayed pretty similar. In detail, there would probably be a few more databases or a few more buckets, but I don't think I have time for this today, so let's skip over that. And that already brings me to the web configurator use case, our faraway mountain peak that suddenly came very quickly and very menacingly towards us. And basically the menacing part about the web configurator is that it's real time in front of the customer. So everything before was pre-rendered. I mean, the local use case, someone sits at their graphics workstation, does an image, sends it somewhere, and it gets inserted. The digital giveaway was produced by a dealership. So a dealer would create the digital giveaway for the customer. have a look whether it looks nice, send it to the customer. So if something went wrong, they could write a bug ticket, we would fix it, everything okay. Customizer was similar. Even if the preload failed, we usually still had a night to fix it. So not super high pressure. But the web configurator, if a customer wants to configure the car and the image doesn't load, then basically you have the problem that Stefan has presented on one of his first slides. You stand there with a car that's very, very expensive and you don't see how it looks like, so you're not going to buy it. So if that doesn't work, we have a problem. The other problem is, of course, we need to be even faster because customers don't like to wait. So one way to get faster is, of course, to cache your images because, as it turns out, a lot of people like the same colors. So maybe the image was already rendered. So if we cache it, we don't need to re-render it. And even luckier for us, this media service that we just had interfaced already also had a caching layer, which we gladly took use of. And the only thing we needed to provide in that case was some metadata about our images, because this caching layer needed to know how long the cache should be valid. Because as you now know, the cars get updated very regularly, and maybe even the rendering engine gets updated, and now it is ray tracing, everything looks way better, so you want new images to be rendered. And this metadata about the images tell the cache when to invalidate the image and when to request a new one. But of course, your cache only helps you so far when the image is already there, and users usually care about the bad performance and not about the average performance. So we also needed to reduce the time it took to render one image. And this we did by further splitting our rendering instances now for separate use cases and separate cars. And that meant basically that our render engines didn't have to do as much loading in between. So if you imagine you have a general purpose render component that renders any car on any environment, you might get one render job for Q4 and one render job for an e-tron, one render job on the moon, one render job on the Allianz Arena. And every time in between, you have to reload the environment, you have to reload the car, and that takes time. Time that we don't really have in the real-time use case. So what we do instead is we have separate instance groups where we separate by car and environment so that we only need to load these things once at the very beginning. And then for each render job, you get the same environment and same car, thereby saving a lot on loading time. Because as it turns out, changing the configuration is a very quick job because it's basically the same car model, and the render engine just figures out whether to place the steering wheel on the left or the right side. All right, so I mean, what else is there to say? I mean, basically for us, it was very helpful to start small. I mean, now, especially when preparing the talk, looking back, I couldn't have imagined how to do everything for the web configurator without having some small steps in between. And it really allowed us to, well, basically do what you want to do in software production, right? You do small iterations, you want to measure whether you were successful, you want to correct the course you're going. And that worked in this case very nicely for us. What also helped us was this shared render component between our first use cases, which allowed us to reduce the complexity for us by coding and gain a lot of speed, and also ensure the quality in the API even before it was even used. Technology-wise, we use TypeScript all the way, front end, back end, and sometimes even in the infrastructure once CDK became a thing, which also helps a lot to be faster because there's a less onboarding, less overhead for the developer. It's easier to get info into, and we used AWS. I mean, of course, you pay a little bit with vendor login, but it's fast. So we use a lot of their services, and it helped us to get our application running very quickly, and also helped it to scale until today. So, and of course, we were able to build on the work before us. So we could reuse the media service to interface the various touch points. And of course, we could build on the AVE, the render engine that was already in development for several years at Abi. So yeah, that's it from my side. I think Stefan has also some outlook on the topic.
Some outlook, yeah, because actually now as we have delivered the WebCC, Lamborghini Web Configurator, we could say like, okay, now we have made it, we have reached the peak, and now we can basically go on holiday and everything works. But unfortunately, that's not the case. So basically, we have done one brand. And when you compare the numbers on the right side, Lamborghini has 3 models and has a throughput of around 1.4 million newly generated images. So not cached images, but newly generated images per week. When you compare this with the other brands in the Volkswagen Group, you know that we are just at the beginning of the web configurator roadmap, basically. And yeah, so more ahead for us. And that's our journey so far in the last 1.5 or 2 years. So thank you so much for your interest in that talk. And if you want, you can take away your personal giveaway with you. It's a new Q4. And yeah, now we have also room for some questions, I guess.
Yes. Thank you very much, Markus and Stefan, for the great talk. Are there any questions in the audience? Mask.
Thanks a lot for the talk. One technical question and one from the use cases of the technical one about the caching. Is it that this caching system also has the files, or is it only holding the metadata and gets images you've stored in your storage systems? And from the use case side, the 1.5 million, have they been only from the Lamborghini configurator or from all configurators?
At the moment, we are only live with Lamborghini, and in terms of configurator, so it's only Lamborghini.
Yeah, but 1.5, it was much more than the Audi, I think. So did you take into account that there are many interests from customers for Lamborghini, so you had to change something about the scalability for the Lamborghini web configurator compared to the Audi one?
So basically, the challenge for that huge amount of more images, like which is required for Audi or for Volkswagen, is that if you scale that solution even more, it's getting more and more expensive, and it's basically a question of costs. And you need to basically make sure that you are rendering or you increase your throughput without increasing the costs in the same linear level, in order to basically also play those kind of configurators. So our job in the next months will be to drastically reduce the cost per asset, the price per asset, basically, in order to be also economically scalable, basically, for that kind of WebCCs.
Yes, regarding the storage of the image, Matthias, correct me if I'm wrong. I think the media service stores it itself, right?
Yes, they have a CDN, basically.
Yeah.
Yes, Eric.
Hi, thanks for your talk. What was your experience now going live with this, with the AWS infrastructure, especially regarding 3D hardware that's required? Is this something that's still kind of in the experimental phase, or is it fully established and the same way that other AWS, let's say, infrastructure is so far?
Should I?
You can start.
But I cannot really answer it from a technical question, but what you can say is that, for example, the limitations on AWS are, of course, there compared to a local workstation. So you have less computing power on an AWS instance in terms of, you need to take that into account. So we had the case that some cases work very good and very efficient on a local machine, but suddenly in the AWS instance, it doesn't work at all because they are maybe a bit too slow, and our pipeline does not work as expected, and so on. So you still need to differentiate between a local and a cloud infrastructure case, basically.
Yeah, I think a big problem, or like one source of issues for us was also that the render engine itself is developed or was mainly developed with the local use case in mind. So we found a lot of new bugs that we only saw on the cloud computing hardware, which kept us awake some.
Yeah,
some
so
nights.
it was not as easy as it was mentioned on the slides here.
Yeah.
So it took a while.
Yes, are there any further questions?
Hi, I have a question about your integration into the media service. I mean, you have on the one hand a highly scalable cloud application for real-time use, and on the other hand, an API. So was that really a flawless integration with them? So could you basically just use what was there and it was performant enough? Or did you have some integration struggles?
So I think the media service already, so basically the media service was already the service that was serving the web configurator until then. And it was already serving these 1.5 million assets per week. And before us, it was a different render engine, different render method. The load, however, was pretty much the same.
Yeah, so the media service is basically built for that load because it was already established. And I mean, we did not build the first configurator. There have been configurators before us. But the technical solution, how to produce the raw images, that is something that has changed with our solution. But the general setup of delivering millions of images for the users of the website, this did not change at all.
Perfect. Thank you. So do you have any results whether it increased the sales by any large margin that you can visualize that, I don't know, the steering wheel is going to be red or something? So do you have any results regarding that it actually is worth doing this? Apart from the technical standpoint, of course.
I don't have any results just with me today, but this is the question, which is basically one of the KPIs that I did not mention. One important KPI would be if I produce an image, how much views does it get? And how much impact does it get on the sales process? But this is a KPI which is really hard to measure. And there are huge departments at Audi AG and probably everywhere in the automotive world that try to find out and try to answer that question. But it's really hard to measure. From a produced image, how much value does it bring to the sales process? It tends to be a clear answer if you look on blurry numbers, basically, that you can increase the price of the car by a better visualization, but it's very hard to really bring those measurements together, basically.
Thank you. Perfect. Any more questions? Okay, then I would like to thank the speakers again. And everybody else, have a great day.